Dear students, we are going to start with another lecture in the course on geometric design. As you have gone through, we have started with the cross sectional elements, and under the cross sectional elements in the previous interaction we talked about the medians, the widths, the functions why these are being provided, the camber, its function, shape, design, etc., the verges and their functions, and finally, the parking lane and the width of the parking lane which can be provided under different conditions. In continuation of these elements which are related to the cross sectional elements, we are going to look at 4 other elements today. They are curb, the guardrails, the side slope and the side drain. Let us start with the curb now. What is a curb? Now, curb is basically a sort of a device which is made of either a stone or it can be constructed by using the cement concrete, and this curb is being used so as to demarcate the edges of any of the constituent element of a cross section. Say when we are talking about a median, then what are the edges of the median? They are going to be defined by the curb. Or if you are talking about a footpath, then the edge which is towards the carriageway is again going to be defined by the curb. So, it is a sort of a device which is trying to demarcate the spaces and the functional values of those spaces, and in that sense it helps in different other ways also. Now, what are those other things? The very first thing is when we say we are using it say as a part of an edge of a median or a footpath, then if this is my road and here I have provided a median and this median is being protected by a curb stone on the edge of it, then what it is trying to do is it is trying to give the lateral support to the material which is filled in the median, and the same may happen in the case of a footpath. So, if this is not being provided, if this curb is not being provided, then all of this material will start flowing outwards with time, and that will be a difficult situation or a hazardous situation for the movement of vehicles on the carriageway because of the loose particles lying on it. Another thing is that when you talk about the different cross sectional elements, so it allows to demarcate the edge of the carriageway with respect to the cross sectional element. So, if I talk here, then I can say that I have a carriageway on this side and I have a carriageway on this side, and if I am going to put a footpath, then my footpath is on this side towards the development, and here also the curb stone is being provided. Similarly, if I have a bicycle track, then that can also be done, and that these can also be used there. We can use it in maybe in the parking areas also. So, there are so many things which are there which can be demarcated using the curb stone, and in that sense when it is being used in all of these environments related to the vehicle movements, then it tries to create also an hindrance to the vehicle in terms of that the vehicle should not cross over to the other side, and if the vehicle crossovers to the other side, then it is going to create a big problem to the safety of the users who are utilizing the spaces on the other side. Say you have a footpath and your vehicle just jumps over this curb stone towards the footpath, then all those people who are moving on the footpath, their life is going to be endangered. So, that is what we are trying to say here. So, it tries to create that sort of hindrance also. So, it can allow the movement, it may not allow the movement, and that is where when we talk about this hindrance, this can be at different levels, and this is what we are going to see that what type of curb stones are there. Another thing which is there is that this can be designed in such a manner that this can facilitate the drainage, because when you are providing it on the side of the carriageway and you have a curb stone here being provided. So, whatever the water is coming from this side, or if this has a slope, then the water is coming from this side is going to accumulate in this area, and therefore, there is a requirement to drain the water, and we can utilize and create a design by way of which we can do that. So, this is another aspect which can be there. It manages the level differences in the adjoining structures. So, one simplest example which we have been talking again and again is a footpath. It can be with respect to the bicycle lane also, or it can be the access to the property where it is being done by way of increasing the height of that access road, and then probably we need to control the movement of material in that by way of fixing the edges of it. So, it also works as a traffic barrier, and we have, as already being talked about, this is the demarcation device for the specific spaces. So, if we look at in this photograph which is there on the left hand side bottom, what we can find is that there are curb stones which have been used here in the parking area, and this demarcates that up to which particular point the vehicle can be parked in this area. Of course, there are parking lanes, parking areas are being demarcated by way of how many vehicles can be parked, but this device when it is being placed, it means the vehicle is not supposed to come to the other side. Whatever is there, it should close at this point only. If you look at the another photograph being provided here, so we may have probably the footpath on this side and we have the carriageway on this side. Now, whatever water is going from this direction or this direction is getting accumulated here. So, the design is being created in a manner, so that we have a composite design of this curve, wherein it is also being provided with holes. So, whatever water is getting accumulated here is finally going out through these holes to the underground drainage system, and that is how the carriageway has been kept dry. Let us look at the another photograph here at the top, where we have the parking spaces being provided here. So, these all are parking spaces, as you can see that there are marking on the surface of the pavement, but then it is being demarcated with respect to the carriageway being provided on the other side by way of a design, and this design is being provided again with the curb along with the channel, so that whatever water is coming gets drained away from the carriageway system. If we look at on this one, here what we find is that we have a footpath, and this footpath is being protected by way of providing these curb stones, and at the other side also it is being provided, so that all of the material which is being placed in this footpath remains intact, and there is no effect of the movement of water from the other side, which is a green patch, and thus the level of the surface of this footpath is going to be maintained. If we talk here, this is a case maybe where we are interested to keep the other side of this curb stone as such, that means we are not going to pave it from the top and can be used for the plantation, etc. Here in this one, some construction is going on and a curve along with the channel has been provided, so that whatever water is going to be there goes along this in either of the direction, whatever the slope is being provided here. This is a beautiful example of the demarcation of further spaces. You have carriageway 1 on this side and carriageway 2 on the other side, and these two carriageways have been just separated out by way of a median, and that median is being supported by the curb stone. So, so many utilities are there of these stones which we are going to utilize in these demarcation aspects or other functional conditions. Now, if you look at the design, then there can be two types of design. One is a simple vertical design, another one is a design which is extended towards the carriageway. So, we have a carriageway on this side and we have an extension of that. Now, what you see is that if this is a surface and says the top of the carriageway, then there is some portion which is going to be embedded. So, this is the portion which has gone in the embedment in this particular case, so that nobody takes out this stone and use it somewhere else. So, it remains in position. Another thing which we can see is there is a certain amount of height being given here, and then there is a design, whereas the design is in terms of this flat surface and it is in terms of this steep surface. Now, these designs of steep surfaces and flat surfaces are going to define that what type of curb stone is this. Now, here this particular curb stone is a barrier curb stone, which says that the vehicles which are moving on the carriageway will not be able to go towards the other side because of this height and design. The extension of this design is being shown here, where the only extension is that we are providing this channel here, and when we are providing this channel, so whatever water comes from this gets here, or whatever water comes from that gets here. So, you will find that that is a level in which the water is going to be there, at a certain location this water will be taken out of this particular channel by way of the subsurface drainage system or the internal drains which are being created connected with the sumps. Now, if you look at this design, now this design is completely different than what we have seen in the previous one. What you found is that this is carriageway on this side, this may be a footpath on other side, but the height of this curb stone is quite low. At the same time, the design is very aerodynamic sort of a design, where if any vehicle is there on the carriageway can very easily move on the top of the channel and then on the top of the curb stone to the other side. So, that is another type of a design, and that is why it is being defined as mountable curb with a channel. And the extensions or the other type of designs can also be there. So, let us look at that what we are using in our conditions, and here we are defining them or classifying them. So, we have the three classes here. One is barrier type, another one is semi barrier type, and the third one is a mountable type. So, let us look at first of all these vertical cases, and then we are going to look at these extension cases. So, in the vertical cases we do not have any channel. So, probably the drainage has been taken care of already. So, what you find is that in first case the height is 200 mm, in the another case the height is 150 mm, which is being divided into two equal parts, and in the third case the height is 100 mm only, again divided in two parts, but the lower part is having a lesser height as compared to the other part. Then what you can see is the steepness of this surface. The steepness of this surface is quite high in this case, whereas if you look at in the other one, then it is relatively low, and in between you have a medium condition. So, that is the design which is there, which is being provided with the proper these type of locations which have been made rounded, so that they are not working as a sort of a kink. And if we want to extend it, if there is a requirement to drain the water, then what we are doing is that extension is in terms of the 300 mm of the material being placed in terms of creating a channel as being shown here. In all of these cases there is going to be a depth of amendment, and that is there as 125 mm in the case of barrier and semi barrier, and 100 mm in the case of mountable type. Now, when you have these type of curb stones of different designs, and we have already talked that in what condition which particular one is going to be utilized. So, let us look at further more on these things. The first one, as we said, is a barrier type of a curve, which is mostly being used in those areas where there is a lot of traffic as well as there is a lot of pedestrian activity. If these two things are quite high and you have to separate them out and there should not be hazardous interaction between them, then we are going for the barrier type of curve, and in this case the height is 200 mm or more. Now, when you are going for this height of 200 mm and more, and it has made more steeper, in that case it becomes unmountable by the vehicles, and thus the safety of the users is being ensured. When we talk about the semi barrier type of a curve, so in the case of this one, we are going to use it again at certain locations where the pedestrians are still there, but the traffic may not be that high. Or it can also be used in a conditions where if you use a barrier type, the first one, then if it is affecting the capacity of the road. Why it is affecting the capacity of the road is because the people may, or the vehicle users, they may create a buffer distance at the side of it. So, if you have a curb stone here and you have a carriageway on this side, the vehicles will be moving maybe at some distance away from it, and that is where this is the buffer which is being created. And if this is being created, the total width of the carriageway which is available to the vehicles to move reduces, and therefore, the capacity is going to be lesser. In these cases the height is roughly in the range of 100 to 150 mm, but it is not more than 200 mm in any case. As soon as it becomes a barrier one. And these type of designs, they can be mountable when the vehicles are moving at a higher speed. But it does not mean that if the vehicles are moving at a higher speed, they can utilize it. They can utilize it only and only in a condition if that is an emergency to do that. The third one is a mountable type, and these mountable type is being provided, say in the case of different channelizations at the medians or outer separators, or the raised medians on the bridges etc. The height is up to 100 mm, and in this case the vehicles can mount them even at a relatively lower speeds, not at the design speed or more than that. So, that is what is the type of the curb stones which we have and which can be provided in different scenarios. Now, let us talk about the guardrails. Now, in the case of guardrails, what exactly it is? It is another safety device. We talked about the curb, it was also working as a safety device when it was segregating the traffic. So, this safety device is being provided under the very specific conditions, and it is trying to segregate the type of traffic which can be there or the users who are going to use the road space or the carriageway. So, that mutual safety is going to be ensured by way of the provision of guardrails. Now, where we are going to provide them, certain points have been listed here. What it says is that if you are in a very busy or congested reaches, and these very busy or congested reaches, because of the interaction of users, it culminates into a hazardous condition or hazardous location, then it is better to provide the guardrails and segregate those people who are going to be getting interacted in that form, or these can be provided at the intersections or the junctions. The reason being that we need to guide the pedestrians who are going to cross, and there are crossing facilities being provided, say in terms of a zebra. It should not happen that people start crossing the road at any of the location wherever they want. So, they can be brought to the zebra by way of providing the guardrails at the edge of the footpath and giving an opening only at that location where the zebra is. So, that is where your guidance can also be there. We should also utilize them near the schools and colleges where there is a lot of movement of the kids or the children or the school going people, and there is also a traffic on the road which is coming either to pick them or has nothing to do with the school or college people and is still utilizing that particular road. So, there are always a possibility that towards the end of the day when the school is over, the children may come running outside, and if they get directly into the carriageway, then this is probably going to be hazardous. So, we need to channelize the things by way of the provision of guardrails also. Another way is that we can use it at the transit locations, transit stations, bus stops, railway stations also, where again the point is that we are trying to channelize the movements, so that all of the movements, all of the activities, they become more you can say systematic and orderly. The same is the reason in the case of overpasses and the subways. Again, we need to take the people to those particular locations where by using these facilities they can cross the road, or on the central reserves like medians, so that the people are not crossing, the pedestrians are not crossing from one side to the other side because the traffic is quite high on this road, and if they do that, there is going to be again a hazardous situation. There can be a major injury or a fatality, or any of those locations where the pedestrian movements are quite high. And all of such cases we should try to provide the guardrails. Let us look at some examples here. Say if we talk about the first one. In this case, what you found is that the guardrail is being provided here and it is being left open. So, this is a bus stop. So, the bus is going to stop in this area and the people will get in or get out of this particular bus at this stop. So, all those people who are coming from this direction, they have to come to this area, then only they can utilize the bus service, otherwise they cannot. Let us look at another example here which is further more systematic. What you find is there is even a railing being provided at the center, and that is where if the bus is stopping here in this area, it may happen that the front door is probably here and the back door is on this particular location. So, you have made it more systemized. There can be a queue formation and the people can get in and out of the system one by one without creating an hue and cry. So, that is a better way of doing it, and it all depends at how much traffic is going to be there on that. Let us talk about the third case where it is being provided on a median, and there may be a development on this side as well as a development on the other side, and people may try to cross on this add grade condition, and we do not want that to happen, and that is where this type of a railing system has been provided at the center of the median. Say if we look at the fourth case, here this is an access or an exit from a subway system. So, in that particular case again the guardrails with the handrails are being provided. So, that the people can who are going to use these facilities, they can just hold on this and get to the top or come to the bottom of this particular facility. Here what you found is that the carriageway is being provided on one side and maybe there is a footpath, and both of the things are at the same level, but they have been segregated by way of the provision of this guardrail here. So, that the two things have got separated out and we are ensuring that the safety of this pedestrian is there. So, that can be the way we can utilize it. Say if we talk here again and see in the first case on this particular slide, then what you found is there is a continuous guardrail or the railing which is being provided in front of this building. This actually is a school. So, the kids are going to be come out of this particular location and there are different parking areas which can be treated as a pickup points, and whosoever is there then they can get the vehicle and go, and that is how sort of ordered movement can be created. If I talk about this photograph 2, what you can see is this is a pedestrian crossing here, and at this pedestrian crossing by way of provision of this guardrail, the movements of the pedestrians have been systemized. So, if they are going to the right hand side, they should go from that side. If they are coming from the right to the left, then they should move from this one, and that is how this orderly movement has been created. If you are looking at this third one, this is again an access or an exit from an underpass where it is not a railing, but it is basically the handrail which is being provided here. So, make the movement comfortable for those who require it. If we talk about the fourth one, then this is an intersection where at this location the crossing is being provided to cross the road from one side to the another side, and if this railing is not being provided, then there is a possibility that the people will start crossing at these locations, and this is being omitted by way of the provision of this particular railing. So, that is how we are going to work on it. Now, when we are talking about all of these guardrails, then what should be the design? That is what we are trying to look here. The very first thing is that what should be the height of these guardrails, and these are 1100 mm above the surface of the median or above the surface of the footpath on which it is being provided. The another thing is where it is going to be located on either a median or a footpath is what is being talked, and it says a setback of minimum 150 mm and desirably 250 mm from the edge of the carriageway. So, if I have this as a carriageway and this is my curb stone and I have a footpath here and I am going to provide a railing. So, if my railing is say something like this here rounded on this one. So, this is my railing. So, this setback which we are going to talk, this setback is what we are talking as 150 to 250 mm. So, that is what should be there. This should be in canary yellow color if they are going to talk about, if they are going to have a function in terms of a segregation, because yellow color is being considered as a restrictive condition being depicted to the road users. They should be rounded at the top, so that if anybody holds on it, then that should not be creating the injury to the person. The vertical design shall be such that the road users cannot climb it. So, if I am talking about this my system of the guardrail, so this is my top and say this is a bottom rail, and this top and bottom rail they are going to be connected by way of the vertical bars like this. So, what it says is that if these are being provided, the gap between these bars, first of all it should not be such that a person can cross through it. Another one is that if you are going to provide these type of horizontals at different locations, they should not be there, because otherwise people will use them as an step and will cross towards the other side. So, this is not allowed. So, that is what it is talking here. Now, once we have talked about the guardrails, then another thing which can talk is the side slope. Now, the side slope is going to be there under what conditions? It is going to be there in all of those conditions where the road is being constructed either in embankment or it is being constructed in a cut section, and that is where the stability of the slopes needs to be taken care of. So, the main thing which we are trying to look at is that stability, that the material which is there should not fall down. Now, when you are looking at this stability of the slope, it is also going to be dependent on different aspects. One is that what is the type of material which is there with which this slope is being constructed, and another one is what is the height of the embankment. So, if I am talking about something like this and this is an embankment, then what is going to be this height which I am talking here totally like this, that is h. Or if I am talking about a cut section, so my cut section is like this and I have cut it in this form. Now, if it is being cut so as to create this road, this was original and this is after the cut, then what is the stability of this is going to be looked at. So, we have to see that whether this is stable or not. So, the material, if it is soil or it is rock, if it is a hard rock or it is a fissured rock, everything is going to make a difference in terms of the movement of the material here. And if this movement happens, then there will be a soil movement or the landslide or the rock fall, all of these things may appear, and we do not want all of these things to happen on our road. Now, when we are talking about these slopes, then these slopes are usually talked in terms of certain value in horizontal versus vertical. So, when we say that we are talking about 2:1, it means if we move 2 units in horizontal, then we are going up by 1 unit. That is how it is being read. Then, when we are looking at the cut sections, then if it is a soil, it can be 2:1 to 1:1, but if it is a hard rock, then it can be quite steeper. It can be 0.25:1, means you are moving very less horizontally, but going high, and it can also be the vertical, almost vertical, depending on if it is quite stable by itself and it is quite hard and there is no possibility of the movement of the material. When we are talking about the embankments, then if the embankment is 1.5 meter high, then in that case it can be 4 horizontal to 1 vertical, but as we keep increasing the height by 1.5 meters, then we can reduce this particular slope by a unit value. So, that is how it keep going, and by the time we are at 6 meters or above, we can then maintain a slope of 2:1. So, we can say that it is a possibility that not necessarily we are going to create it like this. So, we may be creating it slowly in this form, so that it becomes more stable, because if we take it back in this, so the stability is here, but because of these additional mass, it gives more stability to the material which is being used in the upper layer, and that is the same thing in the case of another layer. So, that is how it is the thing which is being maintained. The next thing which we can talk is the side drains. Now, in the case of side drains, this is quite important, because water, if remains there on the carriageway, is not only a problematic situation in terms of the friction which it is going to give for the vehicles which are moving on that surface, but at the same time if it seeps inside, it is also detrimental to the pavement. So, the drainage is quite important. Now, when you are looking at this drainage can be a surface drainage, that means at the top of the carriageway, or it can be a subsurface drainage, that means there is a water which is getting accumulated in the lower layers and we need to drain it out. So, these two things may happen. So, you may have surface drainage or you may have a subsurface drainage. The another thing which may happen is defined as a cross drainage. So, that is another thing which may be there. We are going to look at these things one by one. Now, when these things are going to be provided, we discussed about it in the starting when we looked at the cross sections. It says that we should try to provide it away from the shoulder, so that whatever water is getting accumulated is being drained to the side drains and then it is be taken away. So, in the case of hills, then when we looked at it, then what we found that they should be provided on the hillside, or they should be provided on the basis of terrain such that the water getting accumulated in a particular area is being drained by way of the provision of the side drains. Now, these drains usually they are trapezoidal in shape with a base width as 0.6 meters, top width as 1.2 meters and depth as 0.3 meters. This is a standard design, but then it is also going to be dependent on the amount of volume of water which is coming as a surface flow. Okay, so that amount of water needs to be calculated, and accordingly there may be a requirement to redesign these. In the case of urban roads, they can be provided as a triangular channel or the U drains, and these are provided at the side of the footpath or at the edge of the carriageway, but most of the time we should have some space being given even for the shoulder also. So, as we talk about the size of it, obviously the adequate capacity should be there, so that it can handle the surface runoff water, and that is what I talked in the previous one. Shape and location matters, because the discharge which can be carried by a U shape or a triangular shape or a trapezoidal shape is different. They should be lined. If they are lined, then there will not be a problem of the seeping water which will go into the system and create a problem, and there will also not be any problem related to the erosion of the material in it. These side drains have to discharge at some particular location, and that is where the cross drainage works comes into picture. So, the water will come into a sump, and through sump it will go further away. Then these cross drainage works becomes quite important in the hilly regions, because you cannot take the water continuously all along the hill. You have to find out the locations where this water can be drained in the cross drain, which is available either naturally or can be created artificially. One another type of system which can be there is a catch drain. And what is this catch drain is? They are provided on the high side of the cutting to intercept the flow of surface water and the soil seepage water. Let us look at few of the things here. In this first case, what you found is that there is a V shape of the drain, and it is being provided at a location where this whole of the water get into it. So, that means there is a sump here. Through that sump the water is going to be taken out further. It is being provided with the cover at the top, so that whatever bigger size of particles are there, they remain here, only the water gets into it. This is the end of this drain at this location, and that is where again a sump has been provided. Here what you find is an open drain being provided on the side of the carriageway. In an urban area, we said that it should be provided on the edge of the carriageway, but it is always better that if some shoulder has been there, otherwise there is a possibility of any vehicle getting inside this particular drain. This is a case where a footpath is on this side and carriageway on this side, and then it is being provided along with the curb. Here this is a drain being provided continuously going along with the footpath and the carriageway, and it is an internal drain being provided, maybe a trapezoidal or a U shape or whatever it is, and being covered at the top. Here in the case what you found is a catch water drain, because whatever water is coming from this hillside is going to be accumulated here, and it is not going to come directly on this. Otherwise, the total amount of water which will be there in this area because of this direction and this direction will be quite high, and this drain may not be able to take away this particular water. At the same time, there is a catch pit or a sump being provided, and this is going to be at specific locations, and then this catch pit or sump pit is being provided with the drain pipe towards the outer side, towards the valley side, and that is how the water is being drained on the other side. The same thing is being shown here. We have a catch water drain and a catch pit and a side drain, and the water is being taken outside in this form. So, this is how these four elements which we have talked today can be provided on any of the cross section of a road. With this, we close our interaction today, and we will be continuing with other features of the cross section in the next interaction. Till then, thank you and bye.